Hey guys, today we're going to learn about table F and less than 10 minutes here. All right, so table F basically tells us if something, if a compound is soluble or insoluble in water. Soluble means it will dissolve. Insoluble means it will not dissolve. And compounds can be made up of these ions or these ions, and then these exceptions as well. So what I'm going to do is give you a whole bunch of examples of showing you how to read the chart, what compounds are soluble, which are insoluble, and then how the exceptions contradict the rule. Meaning, these exceptions down here are exceptions to that rule. So these ions make compounds, when combined with these ions, actually insoluble. And all of these exceptions, when bonded to these ions next to it, make those compounds soluble. So it's the opposite. So if the exceptions are being used, then we go over here. And if the exceptions here are being used, then we go over here to soluble. So I'll give you some examples. Okay. So let's do a simple one first here. Sorry, this was notes I was writing to myself. I should just pick up with that. Take a very simple one here. If we look at KCl, and I want to know, and in parentheses here, what I'm going to do is I'm going to label either AQ, which means soluble, or I'm going to label KCl solid, which is insoluble. And this means it will dissolve. Soluble means will dissolve in water. So you put that in, stir it up, it goes away, right? Dissolves, breaks down. Insoluble, you put this in water, stir it up, it just spins around and then settles at the bottom. That's what that means. So we're going to use table F to figure out, is it solid or aqueous, right? Here's how I do it. I have K plus Cl minus. We learned that already. So Cl minus is what I always tell kids to look up. Always look up the anion. So we're going to go to table F, and we're going to look here, we're going to look here, and we see, okay, Cl minus is right here. So Cl minus should be soluble. That means aqueous, unless it's bonded to one of these three ions. Since potassium, K plus, is not one of these exceptions, then Cl minus is in fact soluble when bonded to K. So soluble AQ is correct. Okay. What if it was AgCl though? Then in that parentheses there, am I putting AQ or solid? S or AQ? Soluble or insoluble? Well, how do we do it? Well, Ag plus, Cl minus 1. So we look up again, Cl minus. We just did one, right? So we know this is soluble. But if it is combined with Ag plus, then it's an exception. That means it's not soluble, which means insoluble. So because Ag is bonded to Cl, it's actually a solid, which means insoluble. And again, that's because of the exception. All right. And chemically, why bonding forces? When Ag and Cl are bonded in an ionic crystal, water doesn't do a very good job separating that, whereas potassium, when that's bonded to Cl, right, K plus Cl minus, the last example, water can break that apart. Okay. All right, another example. What if we had MgNO3 2? Mg is plus 2, NO3 is minus 1. And we're trying to figure out AQ or S. Again, we look up the NO3 minus. And it is right here. Here's NO3 minus. It's soluble, and there are no exceptions. That means NO3 minus, if it's in a compound, it's soluble. Period. There's no exceptions. It's always soluble. That one's an easy one. That's AQ. You see NO3, it's always AQ. Another example. A couple examples. If we have NaOH versus FeOH2. So here and here, OH minus, let me put the parentheses here. OH minus is the anion. In this bottom compound, it's bonded to Fe plus 2. In the top, it's bonded to Na plus 1. So we're going to look up OH minus on table F, and then we're going to look to see, first of all, is it a soluble or insoluble ion, and then are there exceptions? So OH minus is right here under insoluble. So it's under insoluble. That means typically you would label that compound, a compound with OH, little s, meaning solid, precipitate, it's insoluble. But we got to check with these exceptions. If OH minus is bonded to any of these ions, that makes it soluble. So let's go back. We have Na plus, Fe plus 2. I'll work backwards here. Fe plus 2, group 1, Ca plus 2, Ba plus 2, Sr plus 2, NH4 plus. So Fe is not in group 1, and it's not listed here. Therefore, FeOH2 must be insoluble because Fe is not an exception. Therefore, OH minus with Fe is insoluble, so that gets an S, insoluble. Now, Na plus is in group 1, but just to prove it to you here, right? You should know this, but I know it's sideways. Na plus is in group 1. In fact, any of these ions, H plus, Li plus, Na plus, K plus, Rb plus, any of them bonded with OH minus, according to table F, would make it soluble. So group 1, Na plus bonded with OH minus is an exception to that rule. It is actually soluble. So NaOH would get AQ, which is soluble. Okay. I'm actually going to stop there. I think that's probably enough for you guys to get the gist on how to use this. I want you to use the worksheet I'm going to post here, this one right here. Again, I'll get rid of that 42. I don't know why my keyboard isn't coming up, but it isn't. So you're going to do exactly what I just did. NaOH, maybe that one we just did, but you're going to use table F, look up all these ions, write write soluble or insoluble. And then down here, I give you one example to follow. And then number 10, just one problem. I'll give you more of these maybe tomorrow. You're going to fill in this blank here with AQ or solid. Actually, you know what? Should I write? I might switch this up so that you write soluble and then AQ. Insoluble, solid, just so you get in the habit of connecting those phrases, those words with the symbol. So I may have you do that too. So you might have to write soluble, parentheses AQ, insoluble, parentheses S. So I think I'll update that. So I'm going to post this in a little bit. Hopefully this video helped, and that's it. Hope you guys are doing well, being safe and healthy. I'll talk to you later.